All right, everybody, we are continuing our discussions that we've been having in class about children's science learning and how for children to actually learn science concepts and have a really concrete understanding of them, we have to give them opportunities to experience it, explore it with their senses, and then to make sure that learning sticks, we've been talking about the importance of recording science learning. So this is kind of our culmination activity that we're doing to sum up everything we've been talking for the past few weeks. And we're going to start off with looking at some cookie dough. So I made some cookie dough for us. You can see it on my other camera here. And it is, well, why don't you guys tell me, what kind of cookies do you think I made today?
Chocolate.
They are chocolate chip cookies using the original Nestle Toll House recipe because apparently that's the best you can get. So we have some chocolate chip cookie dough, and I want you to, one of the vocabulary words that we've been working on is properties, and how properties are anything you can observe. So I want you to, and I'm going to take a scoop of cookie dough and put it in my hand. Don't worry, nobody's going to eat the dough that's in my hand. This is a scoop of cookie dough. Tell me some of the properties that you can observe in the dough through your screen.
Sticky.
Sticky is definitely a good word because if you see, I can up with my finger. What else?
Mushy.
Mushy.
Mm-hmm. Squishy.
Squishy is a good word.
Soft.
It is very soft. What do you think about this texture?
Probably lumpy because of the chips.
Yeah, and so with children, we can introduce, even though we would be doing this lesson with first grade students, remember, we can use big words with little people, and a word for this kind of mixture is heterogeneous. And that means that we can separate the contents in this mixture. We can pull out the chocolate chips and then have a homogeneous of cookie dough, homogeneous solution with the dough of all the other mixed in ingredients, the eggs, the flour, the sugar, the vanilla, the baking soda, all of those things. So what do you think, and you guys can't obviously smell this, or we definitely don't want to taste it because it's got raw eggs in it, but what do you think it would smell like?
Sweet.
Yeah, there are two kinds of sugar and there's vanilla in here, so they are sweet. Plus there's, a whole bag of chocolate chips. So when we're looking at recording those types of things with the students, we want to make sure that we're putting down all of those words and we're making sure we record it. And we would have done this experiment with the children too, where we would have had all the ingredients and recorded the properties of the ingredients with them too. But in the mindset of a demonstration in class, we went straight to the cookie dough. Now, some of the other things, so those are descriptive properties. We want to get some more absolute properties with measurement, and we want to do a before and after comparison of the cookie dough to the actual chocolate chip cookies. So can you brainstorm some ways for me on how we would observe a change in the cookies and what types of measurements can we take right now?
The weight.
We can definitely weigh it. And I have a digital scale here. And so why don't we go ahead and get a preliminary weight on our cookie dough. So I'm going to take a scoop. This is the same ball that I just had in my hand. And I'm going to put it on my scale. And if somebody could read for me, it's going to go, about how much does this cookie dough weigh?
9.5.
Yep, and this is in grams. It's a metric scale. So we have about 9.5 grams as our weight. And I will actually say holding the scale up didn't work. So when I put it down, it did change because of gravity. So if somebody wants to just write down on a scratch piece of paper or something you have with you, the actual weight of this is 22.4 grams. That's the weight of the cookie dough. What other measurements can we take of our cookie dough before we bake it?
Maybe the size.
Yep, and we can measure. I have a tape measure. Why? Because I couldn't find a ruler, which would probably be a little bit more accurate. But what I'm going to do is I'm going to measure the height of it, and it's just under 1 inch high, and the width of it. Whoop! It's always hard to get it lined up to my camera. If you can see it, and I think because of the angle, it's just about 1 inch wide as well. So if somebody wants to jot that down, it's about 1 inch tall and it's about 1 inch across. That's diameter if we're doing measurements, looking at that when we were talking about math skills in the first part of the semester. So we've measured, it's about 1 inch tall, it's about 1 inch across in its diameter. Any other measurements you can think of that we would need?
We could do temperature.
We could do temperature. I don't have a thermometer out with me right now, and I'm assuming the cookie dough is going to be roughly the room temperature of where I'm at right now. So probably about 70 degrees, although my oven is on right next to me and I'm feeling a little warmer than that, the average room temperature in my house. What I'm going to do right now is scoop out some cookies and put them on our cookie sheet and actually bake them while we do the next part of our documentation. So I'm just going to bump out, and because we're doing a lot of measurements, why do you think it's important that I'm using the same scooper for all of my cookies instead of just making little balls?
So they're all the same size.
Right, because scientists use consistency, and we want to remind that with children. Good science is replicable. That means that we can do the same experiment over and over again and get pretty consistent results. And so even though we're doing this with first graders, we can start teaching them about those basic principles of science, reminding them of those words. And so one of those little big words for little people that we've talked about a lot of times is hypothesis. Let me put these in the oven. And Alexa, set a timer for 7 minutes. I don't know what I did before her in my life. But I mentioned the word hypothesis, and we've used it before talking about science. Does anybody remember what hypothesis is?
The educated guess that you make.
An educated guess. When we use the definition with children, does anybody remember the kids' definition?
An idea you can test.
It's an idea you can test, just like they say on Dinosaur Train on PBS. So a hypothesis is an idea you can test. Make a hypothesis for me about what's happening in my oven.
These are expanding.
Okay, cookies are expanding.
They're getting less soft in the
Okay.
oven.
So they're getting firmer. What other ideas do we have?
You're making the cookies edible.
Yes, and that is an important fact, that we can eat them once they are baked. And some of the other things are, so let's make a prediction, an idea we can test. We took some measurements before we put the cookies in the oven. How do you think let's do the first measurement we took was weight. Compare the weight after baking. Do you think it's going to be the same, more, or less?
Less.
Less? Why less?
The water could be evaporating from the cookie in the oven.
Okay, so we're losing some water through evaporation. Anybody have a different guess? No? All right, so we think these are the lightest, fluffiest chocolate chip cookies we can come up with, right? So I'm gonna do a screen share for you right now because we talked about the importance of recording. And we want to record data with children. And so the first thing we're going to do is, and this is a form you guys have seen a lot of times on the lesson plans that we generate, it's an instructional alignment. I want you to look, our objective for this lesson is recording scientific processes in baking cookies. We have standards here from the Pennsylvania Early Learning Standards for first grade about interpreting data using tables and charts, observing properties, identifying heating, melting, and cooling, observing what happens when things are heated and cooled, and participating in simple investigations. The important thing with science and learning about science is making the learning stick through documentation. So if we wanted to assess on all of these things, all of these different elements and standards here, how could we show that the children are now capable of doing all of these things? Let's look at that first standard. What would we need to do if we're thinking about, we want to assess how well they represent and interpret data? What can we do?
You can ask them questions about the data and like
Oh.
see what they learn from it. Like just asking them questions like if they knew before what the cookie, how much the cookies weighed, and when you weigh them again, if they can say, okay, it's like 3 ounces less than what it was when we weighed it the first time.
Okay. Would it be helpful if we actually made a chart with the children?
Mhm.
So if we had, let's say we did it on our whiteboard, we did it on some banner paper or poster paper, or even just an individual sheet for the children to record. If I was doing this in a classroom, I would give each child a scoop of cookie dough and plastic gloves, because kids are gross, they have germs. But we want to make sure that we're being safe and sanitary, but we'd give them each a scoop of cookie dough. They could each, depending on the classroom setup, have a turn at the scale, use a ruler at their desk. So we could have children complete weights and measurements and record on a worksheet or a class chart. What else could we do to make sure they're really understanding? Think about those observing and describing properties. And you guys gave me a lot of great words. Is that something we would want to just leave in a discussion, or what could we do about with all those words you gave me about the cookie dough?
Have them write them down.
Yep. Make a word list. And that's something we could add to our word wall in the classroom, and we could maybe have a list of describing words, a list of properties and observations, but we could definitely write down a word list. If we're thinking about what happens when things are heated or cooled, and we're thinking about documentation and making those observations, what's one way we could remind the students what they've seen?
Pictures.
Yeah, great, Rashad. We can definitely take some pictures. We'll take some pictures of the cookie dough and maybe record something like that. We can use one of the apps on the iPads in the classroom that do a story building app and do kind of this is the book of our chocolate chip cookies. So we put a picture, we put some of those observational words, we put some of those predictions, and we can take pictures. I could even, as the cookies were in the oven, put on the oven light and go over and do that. So we could take photos and make a class book. If we were making that class book about chocolate chip cookies, and class books are something that are used in a lot of classrooms with these type of whole group investigations, are we covering pretty much everything there in our standards? For the most part. All right, so I'm gonna take down our screen share here so that you're able to see a little bit bigger on your screen and come back to, so we're gonna do some comparisons and measurements when the things come out of the oven, and they should be getting pretty close to having my timer go off. How do I want to, there it is. All right, Alexa, stop. Man, am I good with timing. All right, so Alexa, stop. I'm gonna hold the cookies up on the tray here. So do some observation here. How do they look now?
Wider.
They are wider.
They look
Flatter.
fluffy.
Fluffy. I missed another word in there.
Flat or flatter.
Yeah. If we compare, and I'm just gonna put the cookie dough side by side on the pan here. Look at the differences between the uncooked dough and the flattened or the baked cookie. So they are definitely flatter. They're definitely wider. What do you think about the weight?
Way less.
Way less? So I could use my digital scale, which I'll do that from one. And somebody remind me what our weight was before we started.
22.4 grams.
All right. And our weight right now is 16.6 grams. So was our hypothesis correct?
Yes.
Yes.
Yeah, it actually weighs less. If we have some really cool science instruments, we could actually check moisture. They actually have readers that you can put on that to check the water content. So we can compare the weights with that. I also have, and this is a tool that students like to play with a lot more, I have a balance scale here. And so what I'm going to do is actually put, because this isn't as precise as digital scale, so I put cookie dough on one side, and I'm going to take a baked cookie, put it over here, and we can get the visual representation here as well, that we can see that the cookie dough is a little bit lower, or actually, is it lower? Cookie dough's over here.
I
And my
think the
cookies-
cookie dough's higher in the
Yeah, it
cookie
looks
itself.
higher.
Hold on. Let me center the dough. This is about precision with measurement. Now I almost ate the cookie dough. I didn't lick my finger. All right, so how does it look on here?
It looks like the cookie weighs more.
It looks like the cookie weighs more, and it's one of those ways that we can talk to children about the precision in instruments. This is not as precise as the digital scale. And we can have them kind of look, when we confront children's hypotheses and understanding, sometimes they have what's called dissonance, where it doesn't seem like it should be logical. Like one tool measures a little bit different than the other. And that's a conversation you can have when our tools aren't quite the same. But we always go with the more precise tool, which in this case would be our digital scale. Now, the other thing we needed to do was measure with the tape measure. And so I'm going to use the cookie that's right here. Let me move it to a spot where we can all kind of see it. All right. I don't know if you're able to read this with how far across it is, but it goes to here, which would be about
2.5.
Yeah, it's about 2.5 inches. So when you made the prediction that it was going to be wider, we were correct. If we were to measure how tall it is, it's like not even 1/4 inch. It's very, very thin. So again, were our predictions correct?
Yes.
Yeah. All right. So what questions do you have about doing an experiment like this with children and getting them to record their data and have questions about or building hypotheses, recording data, or observing those changes? What questions do you have about this process?
How do you explain to the kid when they're asking about like the weight of the cookie and the cookie dough, for example? How do you explain that where they can understand that the instrument is not exactly precise all the time?
First of all, this isn't it's a toy. It's a kid's toy that's made for classroom use. So it's not super precise. The other thing is that it could be just variations. This cookie could have had a little bit more scooped on it. We could check by using a different cookie from the cookie sheet, because that goes down quite a bit. And see on this one,
Mm.
do you see what's happening now?
Mm.
This one, it is slightly lower on it. So it could be I just picked a big cookie. Because as much as I try to be precise with scooping them with the measuring tool, we do have variations and variability in our science practices. So this time around, they actually look, and I know it's hard to see through the camera, it is slightly lower on the cookie dough side this time around. And that some scales measure things very, very small, and some things measure kind of on a bigger scale. So there's that variability just in the scope, just kind of differences in how the tools are and how precise they need to be. It's like when we have rulers that only have inches measured on them, and we have rulers that go down to like a 1/16 of an inch. It's that difference in scope and scale. One of the other conversations that we can have with kids is about the idea of change and talking about reversible and irreversible change. Reversible change is if we had an ice cube, we melted it, we can refreeze it. That's a reversible change. Am I ever going to turn this cookie back into dough?
No.
Mm-mm.
No, that would be fun. But I will show you that because we talked about the consistency of the cookie. Look at the chocolate in there.
Mhm.
Well, I can never quite line up. There we go. Look at the chocolate when I broke the cookie dough. Is the chocolate solid?
Mm-mm.
No.
But for the most part, the chocolate in the chocolate chip cookie breaks down or it turns forms. It goes in a phase change. It goes from a solid to a liquid. And then as the cookie cools, it goes back to a solid. The rest of the dough does not do that. It goes from the softer consistency of the dough to the harder consistency of the cookie. So if we were to, think about this in the term of scope and curriculum, we could definitely bridge that out into something that we would talk about irreversible and reversible change. We can talk about phases of matter. We can go more in depth into, phase or consistency mixtures and solutions. There's a lot of actual physical science that goes in to baking processes that children are familiar with. Bridging those, we talked about some pretty complex science if you think about it, not just from the measurement perspective, but from the change, the application of heat, changing consistencies, changing mixtures. And we broke it down on an age level appropriate scale. We talked about the assessment ideas and how we can either do that with group charts and graphs, word lists, building a class book, or even just individualizing it down to a worksheet level so that we're not just playing in the kitchen and making chocolate chip cookies. We're actually having good, solid assessment data aligned to the Pennsylvania Early Learning Standards. So it's a holistic look at how to make that lesson from just kind of a fun experiment to something that really demonstrates what the children are able to know and do.
Mhm.
Have any other questions about this process or how we could do it? All right, good, because homework, you can make a lesson for children. What I'm going to have you do is develop a lesson plan teaching physical science through experiential learning, and you have to have an assessment practice that documents the data for the children so they can show what they know in alignment with those early learning standards. And that's going to be due next week.